How is laser power or energy measurement affected by incidence angle? The short answer is it depends on the type of sensor, or more specifically on the type of absorber that's being used. In this video, we'll look at each sensor type and we'll understand to what degree incidence angle matters when you're trying to measure laser power or energy. Let's begin with photodiode sensors. Semiconductor response depends on absorption of the beam, which is to a small extent angle dependent. Much more significant though, we have attenuating filters integrated onto our photodiode sensors to enable them to measure higher powers than they otherwise would in order to give a more useful dynamic range. These filters are absorptive, and since optical path through them depends on the angle of incidence, the response will vary with angle of incidence in a more or less cosine relationship. Here you can see a graph of this relationship, which appears in the Ophir catalog and website for reference. I say more or less because other factors also come into play, such as loss due to reflection off the front surface, which changes with angle. We'll now consider thermal sensors used for measuring power and single-shot energy. We'll look separately at surface absorbers, such as the BB or broadband and the LP1 types, and volume absorbers, such as the P type. Surface absorbers are opaque and they absorb light right at their front surface. Here we see how absorption by the thermal BB absorber depends on angle. As you can see from this graph, the angle dependence is actually very small. At 20 degrees incidence, for example, the reading will be less than 1% lower than at normal incidence. In the case of a diverging beam, which is a solid cone of light, keep in mind that only a small fraction of the total power is actually coming at the maximum divergence angle. In weighted simulations that we've done, we've found that in most cases, the overall effect on the reading will be less than 0.5%, so it's quite close to negligible. Volume absorbers. The P-type volume absorber is essentially a neutral density glass window, similar to the attenuating filter used in our photodiode sensors. Here though, the heat generated by the light's absorption in the filter is in fact exactly what's being measured, so optical path is in fact irrelevant, though other factors such as reflection do still come into play. At 20 degrees incidence, for example, the reduction in response for a thermal P-type sensor is less than 1%. We also have a different sort of thermal volume absorber called PF, which is for higher average powers than the P-type. As you can see in this graph, it's almost entirely independent of incidence angle. Even at 40 degrees incidence, the response drops by less than 0.5%. Now let's have a look at pyroelectric sensors. There are several types of absorbers in use: metallic and the black broadband types called BF and BB. Very simply, all are quite nicely flat with changing angles. Here you can see graphs of response versus angle of incidence for the BB and BF absorbers. The metallic absorber is equally flat with angle. Some pyroelectric sensors come with a diffuser, either removable or fixed, to enable working at higher energy densities without damage. Behavior of diffusers with changing incidence angle is somewhat complicated, since the angle affects reflection off their front surface, as well as diffuse transmission through them. Here you can see the angle dependence of one type of diffuser-based pyrosensor. As you can see, the dependence in this case is significant. At 20 degrees incidence, it drops by some 5%, and at 30 degrees incidence, the response drops by more than 10%. There are special cases, of course, where completely different considerations come into play. These include, among others, integrating sphere-based sensors. These are specifically designed to capture widely diverging beams, and their readings are essentially independent of incidence angle altogether, up to the maximum specified acceptance angle for any given sphere type. Measurements using a beam splitter are another special case, since polarization can affect the percent reflection off the splitter. If you have any specific questions, please contact your local Ophir representative to see how we can help you in your application.